Hey there, Realcomm Live. I'm Jason Shearer with Cisco. I'm the Workplace's Field CTO, and I'm here with
Bob Voss. I'm with Panduit. I'm a distinguished engineer in the R&D group, and I chair the Fault Managed Power Alliance.
So a lot of you might be asking yourself, like, why are Cisco and Panduit here together today to talk about FMP or Fault Managed Power? So do you have a short answer for that, Bob?
Well, we've been friends for years.
Yeah.
It's an important technology, and I think if you look at what happened while the industry began standardizing fault managed power, the leaders in that area were Cisco and Panduit. I mean, along with others, you know, there's of course VoltServer's the OG, and they were in the UL 1400 process too. But it makes sense. It's a really kind of the missing link for me for DC technology, because you need that DC backbone that can enable PoE to do even more amazing things.
Yeah, and it's not our first rodeo at digitizing an industry. So what, like 10, 15 years ago, Cisco, Panduit, and Rockwell digitized manufacturing. So everything that we know now as Industry 4.0 was because of that consortium approach to build that industry.
Yeah, that was an awesome and continuing effort for the three companies, and really it's manifest in the Cisco validated design process. So it's I like to tell people that the converged plant-wide Ethernet reference architecture is the world's greatest show your work math problem.
Exactly.
Because it's all validated by Cisco's process, and there's some superb work there. So. And we've already laid the first brick in doing the CVD process for fault managed power together. Yep. And so I'm really excited to continue. I mean, like you say, we started 15 years ago, and we know we could succeed doing the way we do it. So, and it's such an important technology for the industry. And as I said, I think it's an important missing piece. FMP is. Yeah.
And it builds on a lot of the history that Cisco, Panduit, and others have been on this journey of data and power together on structured cabling. So, you know, we invented PoE back in the late 90s. IEEE ratified it in 2003 with AF. And I think we've all seen the adoption of PoE for Class 2 devices really take off over the past 20 years. But we've hit kind of a ceiling with PoE because Class 2 is limited to 100 watts and 60 volts.
Right.
Yeah.
Yeah, and that's good. So we need a technology that could pick up where that 100-watt ceiling leaves off, and we pick up some greater distance. So the ability to deploy access layer switches that provide PoE power and control to devices downstream from the switch. I mean, we could be up to 2 kilometers away, given the current capabilities. Maybe that's not so important in smaller buildings, but I mean, if you got a big sheet cake warehouse or something like that, a fulfillment warehouse, that's pretty important stuff to be able to move that distance.
Yeah, we're even seeing for like commercial buildings that have auxiliary spaces, whether it's a parking garage or some sort of a space that is like outside of the main structure, like FMP is a great way to extend power and data out there.
Well, look who's here.
Heard you guys were having a chat.
We were. Welcome.
Thank you.
Who do we have joining us on this FMP discussion today?
Ronna Davis with VoltServer, and I apologize that I'm tardy. I was in another session. It was so engaging.
Just couldn't get away.
Basically AI, digital twins, and it was, time got away from me.
Excellent. Well, thanks for joining us.
Yeah,
we were just kind of talking about the why around fault managed power. That, you know, Cisco and Panduit together, like we started this partnership 15 years ago to revolutionize manufacturing, and now here we are again with energy. So where do you see fault managed power really helping transform spaces today, Ronna?
Yeah, so I have a favorite saying, safe power changes everything.
Yep.
And
I've heard that a few times.
You're gonna hear it a lot because it really does when we think about building infrastructure, and then even out beyond the building, but let's just talk about the building right now. When you make power safer to interact with, when you make power smarter, that really does change the landscape inside of a building in terms of what can be powered and the efficiency at which you can operate all of your building subsystems once they're on a common, intelligent, safe electrical infrastructure. And fault managed power is a digital technology, and so that means it's smart. It's inherently smart. It's got the data. And so now you have a lot more management and control over every one of your devices from a power standpoint, and then of course the data piece, right? So I think it's a critical part to smarter buildings, because being safer means that we can deploy it easier, it's safer to interact with, but then its inherent intelligence, I think, is really what changes the game for power distribution in the building.
Yeah, absolutely. And Bob, we were talking a little bit about, the evolution of PoE hitting that ceiling of Class 2 power.
Yep.
For folks that have never heard of FMP before, and I think that there are probably still a lot of them out there.
Yeah.
Like, what are the ceilings for FMP around the Class 4 by NEC?
So Class 4 or fault managed power is not limited in energy, okay? PoE, Class 2 power, stays safe because it says under 60 volts, under 100 watts, because testing has shown you can't get hurt, you can't start a fire, right?
Yep.
Fault managed power being intelligent, there's no ceiling except for a voltage ceiling at 450 volts that says, send all the power you want, because the intelligence of the system will catch the fault and stop energy delivery into a fault. And it's a variety of faults: an arcing fault, a fault to ground, a line-to-line fault, big dumb Bob touching a wire. It catches it all, so there's really no limitation. I mean, I hate to be all giddy, but really the sky's the limit.
Yeah.
And it's written into the code in a way, Class 4 power is, that we could have a Class 5 power in the future if we needed to, where we say, hey, 450 is not enough, maybe we need to do 800 or 1,000 volts DC. Yeah. So we've already laid the framework in the codes to be able to expand this technology even further. And it's super capable now.
Got it. And the inherent technology is safe. So I know when people are probably hearing like 450 volts, and that might make them a little bit nervous, but to your point, Ronna, like, the technology is designed in a way to where it's constantly testing that circuit, and when one of those faults is detected, it stops providing power to the circuit.
Yeah, no, that's right. It is safe enough to let your kids install it. It is. And that really, when you think about the physical spaces in a building and the workforce that is deploying those systems or operating those systems on day 2, reducing that risk for the building operator, for the building owner, and for the worker themselves is really a big deal. Yeah.
And like safe enough for our kids to deploy it. Like, I have some kids that are going to be joining or getting into the workforce in a couple of years. How does fault managed power help from a labor standpoint? Like, we have a lot of concerns around like the trades and decline. Sure. Does fault managed power kind of provide maybe a more like high tech solution for up and coming workforce?
It installs like data cable, which is handy because we need more data, right? Smart buildings need to be able to get data to increase its value by adding context, and then you have knowledge and wisdom. So all of that stuff's there, and it's got to be transparent, which means we've got to put in a lot of cable, and we need to power a lot of assets. But it all installs the same way. So because of the fact that it can catch a fault and stop energy delivery immediately, fault managed power doesn't need to run in conduit, right? So we don't have that pipe infrastructure in a building anymore. We don't have that requirement. Really, conduit's job is keeping the wires organized, but its primary job is you don't touch hazardous energy. And we don't have that stricture with fault managed power. So we're really in a good spot, and I think it'll be the greasy, noisy, threading rigid conduit and putting wire fixtures on. Some kids nowadays, at least the kids I know, are like, no, I can type on a keyboard for you. So, and I think because of the fact that we have more IT in there. One of the lessons we learned in CPWE was you got to be able to keep the workers, the IT workers, safe.
Yep.
So now here's a system that's inherently safe that runs right alongside the data stuff. So we know that we can make these deployments, we could get knowledge and information in ways we've never been able to do before, and everybody's safe doing it.
Yeah, I think what is really cool about fault managed power is it merges that person that wants a job that isn't sitting at a desk necessarily, but is still a tech job and not really, really dangerous. So if you're a young person, you're trying to consider what type of a career path do I want to go into, and you know that you don't want to sit at a desk all day. And I think there's a lot of people that they don't want to sit at a desk all day. Then I think that fault managed power systems, but also PoE systems, these building infrastructure allows you to have a career where you are in the field, where you are using your body physically, and that feels good. And then at the same time, you're learning the technology. You're learning about the integration. It is a data set. So you can evolve the skill set from that physical space into more of a desk job when you're ready, right? Or into leadership roles within the construction, design, engineering, and even as Bob and I, we work for manufacturers, right? So I think it's a skill set that instead of it just being primarily a physical role, you're also learning the data, you're learning the integration piece, so that will evolve with you in your career.
Awesome. So I'd say the only other thing to let everybody know is, between Panduit, Cisco, VoltServer, Belden, Prismium, and did I miss anybody in the alliance?
Oh, we're up to a dozen now and growing every day. So yeah.
So check out the FMP Alliance webpage and join us on this power journey over the next couple of years.
It's going to be cool. You don't want to miss it.
Yeah, fmpalliance.org.
Yep.
Thank you, guys.
Thanks to Jason and Ronna for joining us today, and thanks for Realcomm Live.